Hello YouTube, this is Mr. Bakari, and today we're going to solve trig equations by factoring. So let's look at our first example. And as you can see in this equation, you cannot simply just isolate a single trig function, okay? What we've got here is a cosine squared x and a cosine x. So we're going to use factoring to help us solve this, okay? And if this doesn't look familiar or if it looks a bit confusing, a strategy you can use is you can take the cosines here and just simply plug in an x, substitute in an x for them, just like that. Then as you can see, it looks more familiar. It looks like a quadratic equation. And then we will try and solve this by factoring. So here we have a GCF x, okay? So now that it's factored, I'll set my factors equal to 0, and I get x equals 0 and x equals -1/2, okay? But this is not an algebraic equation, this is a trig equation, so I do need to substitute back cosine, which I removed at the beginning. So this isn't x equals 0, this is cosine x equals 0. And this is cosine x equals -1/2. Okay? Next, we will find the angles at which cosine is 0 and cosine is -1/2. Well, cosine is 0 at pi over 2 and at 3 pi over 2. Okay? And cosine is negative in quadrant 2 and 3. Okay? Cosine x r. So I can see here that my reference angle is 60. So these two angles are 2 pi over 3 and 4 pi over 3. Okay. So what I'm going to do is list all of my angles. So I've got x equals pi over 2. And I'm going to add a period of cosine n. Okay. N is just any integer. All right. And then I'm going to take my next solution, which is 3 pi over 2, add 2 pi n, and then come over here, and this is 2 pi over 3 plus 2 pi n, and the last one is 4 pi over 3 plus 2 pi n. Okay? These would be my solutions if I were asking for all angles, okay? But I'm not asking for all angles. In the top right-hand corner of all these examples we look at today, we are given an interval. And this interval is where we are solving. Okay, we're looking for solutions in the interval of 0 to 4 pi. Okay? So what we're going to do is we're going to take these angles, which we call our principal angles, that is the angles in one revolution, and by adding 2 pi or subtracting 2 pi, we're going to find all of the solutions that lie in our given interval. Okay? So we'll start with pi over 2, x equals pi over 2. And pi over 2 does lie in the interval that we're solving. Okay? Now, if I subtract 2 pi, that is going to take me out of the interval. That's going to go into the negative angles, and I don't want negative angles. I want 0 to 4 pi, okay? So by adding 2 pi, I get 5 pi over 2, okay? And 5 pi over 2 is within my interval. And then if I add another 2 pi, that is going to exceed 4 pi. So I'm not going to add another angle, all right? And now I'll go down to 3 pi over 2, and 3 pi over 2 falls in the interval as well. Okay? Again, I cannot subtract 2 pi, or I will go less than 0. So I'm going to add 2 pi, which gives me 7 pi over 2. And 7 pi over 2 is a solution in the interval. Okay. And I can no longer add another period or I will exceed the interval. Okay. So I'm going to go to my next angle, which is 2 pi over 3. And 2 pi over 3 does lie in the interval. And if I add 2 pi to that, I will get 8 pi over 3. All right. And 8 pi over 3 is less than 4 pi, so we're good. But we can not add another 2 pi. Our last angle down here is 4 pi over 3, which lies in our interval. And we can add 2 pi to that and get 10 pi over 3, and then we must stop there. So this is the list of solutions between 0 and 4 pi, and we are done. Okay? All right, let's look at another example. Okay, on this one, notice if you look at the interval, we are now looking at degrees, so we want to be aware of that. Now, let's look at the equation here, and this looks like a quadratic trinomial, right? So again, if you'd like, this time we've got cosecant. We can just replace the cosecants with x. And then factor our trinomial, okay? So if we factor this, this factors to x plus 2 and x minus 1 equals 0. Set the factors equal to 0 and solve. X equals negative 2 and x equals 1. Okay? So now we will take the x's and replace with cosecant x. So that gives us cosecant x equals negative 2 and cosecant x equals 1. All right? So now we are looking for angles where cosecant is negative 2 and where cosecant is 1. Okay, cosecant is negative in quadrants 4 and quadrants 3. Cosecant is r over y, so r, y. And you can see here that our reference angle is 30 degrees. All right. So we're looking for this angle and this angle. This angle is 210 degrees. Remember, we're looking in degrees. And this angle that's 30 degrees shy of 360 is 330. Okay? Whereas cosecant 1, cosecant is 1 at 90 degrees. So that's 90 degrees. Okay? So let's look at our principal angles here. We've got x equals 210 degrees plus a period of cosecant, which is 360 degrees n. Our next principal angle is 330 degrees plus 360 n. And then over here, we've got x equals 90 plus 360 n. Okay? Again, if we were looking for all angles, this would be our solution set, but we are looking at angles between negative 90 and 270. So we're going to approach this the exact same way. So I'm going to start my solutions here with 210. Okay, verify that 210 is within my interval. It is, so 210 degrees is a solution. Okay, now note, by subtracting 360, we do not get a solution, do we? Because that will exceed less than negative 90. And if we add 360, that's going to take us above 270. So 210 is all we've got here. So let's go look at the next angle, which is 330. Now 330 is not included here. But if we subtract 360 from 330, we have negative 30 degrees, which is in our interval. Okay, so that is a solution. We can't add 360, but we can subtract it here. All right. And then we've got 90 degrees, which is definitely in our interval. And if we subtract 360 or add 360, that will exceed the limits here of our interval. So our solutions are these three angles right here. Okay, and we're finished. All right, let's look at another example. All right, this time our interval is back to radians. It is negative pi over 4 to pi. So we're looking for all the solutions between negative pi over 4 and pi. Now here, we've got tangent squared x plus tangent x minus 1 equals tangent x. So I'm going to move this tangent over to the other side. Okay, so that's gone. These cancel out. I'm left with tangent squared x minus 1 equals 0. So I'll move over the 1. Tangent squared x equals 1. And I don't want tangent squared x, I want tan x. So I need to take the square root of both sides. Okay? So that's going to give me tan x equals plus or minus 1. Okay, so I'm looking for angles where tangent is plus or minus 1, and that would be at all of my 45s. Okay, because when tangent is 1, we've got a 45-degree angle here. All right, so we're looking at radians. So we're looking at pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Okay, so let's go ahead and write down our principal angles here. X equals pi over 4 plus a period of tangent, which is pi, remember, n. Okay, remember, n is any integer, so negative, positive, or 0, which accounts for adding or subtracting a period. Okay, our next angle is 3 pi over 4. And then we've got 5 pi over 4. And then we've got 7 pi over 4. All right, so these are all of our angles. And we are looking in the interval between negative pi over 4 and pi. So we're going to start with our first angle, x equals pi over 4, and pi over 4 does exist here in this interval, so we're going to add it to our solution set. Okay, and then by adding pi, that puts us over pi. That would put us at 5 pi over 4, which is too much. So if we subtract pi, that would exceed the other way into the negative. So that is not going to help us. So now we'll go to the next angle, which is 3 pi over 4. And 3 pi over 4 does fit into this interval. So this is a solution. Okay. Now, if we add pi, we're going to exceed the top end of our interval. But if we subtract pi, we will get negative pi over 4. And as you can see, negative pi over 4 is included in our interval, so I will include that. Okay? And then the third angle here, 5 pi over 4, exceeds pi, so we're not going to do anything with that. And 7 pi over 4 as well exceeds the interval. Okay? So our three solutions are pi over 4, 3 pi over 4, and negative pi over 4. And we're done. Okay, one more example. All right. here we are back to degrees. We are looking in the interval of negative 90 to 150 degrees. So let's come over here and get started. Okay, so I like to observe what I'm looking at here. I've got a sine squared, I've got a sine, I got a sine squared, and I got a constant here. So I'm going to move this square over. Okay, I'm going to subtract that from both sides. And in doing so, they cancel out both. So now I'm left with negative root 3 sine x equals negative root 3. Okay, and then I'm going to divide off this, and I'm left with sine x equals negative root 3 over negative root 3 is simply 1. Okay, so I'm looking for angles where sine is 1. And there's only one angle in my 0 to 2 pi principal set of angles here, and that is pi over 2, or 90 degrees in this case, because we are looking at degrees. Okay, so that's it. So I'm going to come over here, x equals 90 degrees plus a period of sine, which is 360 degrees, n. Okay? So 90 falls in my interval, so that is my first solution, x equals 90 degrees. Now, if I subtract 360, that's going to take me less than negative 90. And if I add 360, that's going to take me more than 150. So it looks like I only have one solution here, which is x equals 90 degrees, and we're done. Okay? So hopefully this helps you out. Okay, factoring is definitely a strategy we use when solving trig equations, and I will see you in the next video.